research intern at Nigerian Institute of Medical Research. So I would like to ask, is anyone from Ghana here? Or anyone from Kenya or anywhere? Okay. So that means we all literally grew up in, like, let's say, Nigerian household. And then when you were in secondary school and you're in science class, if you're not studying medicine or pharmacy, you're probably going to end up as a teacher. So let's say it was the case for me because I actually wanted to study pharmacy, but I didn't get in. I got into another course. And then I was like, oh, so what am I going to do with this course now? Obviously, I don't want to end up as a primary school teacher. And then I found data. So basically, data gave me hope. And it made me like really read and like, okay, I can actually do something with my course of study. I don't necessarily have to study medicine or pharmacy before I can do something. And that's basically what I'm here to speak to you about. So now we have different kind of data application in sciences. And when I talk science, I'm talking about your basic biology, your basic chemistry, and let's say physics. There are more, but I'll be focusing majorly on biology and chemistry. So now, we all do lab work, right? Let's say when you're in secondary school or anyone study any science course here. That's great. So those are where your data are generated from. Lab works, querying databases and the likes. So firstly, I'll be starting with data in biology. So now, as you heard, there is something responsible for making your hair grow. And there is something responsible for making your nail grow. There's something responsible for making your own eyeball, let's say, black, and then somebody's eyeball is blue. That's the difference in human. And basically, that is called your own genomic data. So this genetic data is basically what is being used to understand disease, how it is cured, and the likes. Please, can you go to slide 7, please? 7, please. Back. Okay, yes. If you look down, you will see something like MN, whatever, that long stuff. Yeah. So that is a sequence of a protein in your body that makes your nail grow. And basically, these are your biological data. Now, if you look up, you will see CCCC. I think it's going to take a long time for me to ask what that means, but that is a paracetamol. And that's like your basic chemical data. So now, it's in these fields that you see stuff like bioinformatics, computational biology, and stuff like that. So now, what these data do is they assist in research, understanding disease, understanding drug creations, and more like that. So now an example of a case study of how you can apply your data science skills in biology. Please, slide 10, please. Yes, this. So when I was explaining in biology, ways that you can generate data is through sequencing. So now, how do you get this? For example, they take your blood. Your whole human makeup can be gotten from your blood. So that's just like, let's say, normal lab work. You do DNA extraction where they get your DNA and put it in the machine. And at the end, what you get is that first part that you can see, the one with red arrows. So now, basically, this data, the first, second, third, and fourth, I'm really sorry, I really wish you can see this very well, is your output. And what you need for your analysis is just the second line. And these data are usually very, very large. For example, you can have 5,000 lines of that first part of your data. And what you need is just the second line. And you are dealing with human sequence. You cannot afford to make mistakes. So you can't open this data and be doing backspace because you only want to get a particular part of that data. So what you are going to do is you're going to probably write a bash script to extract the particular part of the data that you want, and you're going to use Python to analyze it. That's for biology. Now let's go to chemistry. So growing up, there's probably one agbo that you used to take when you have headache or thereabouts. So it's not about the agbo. There's something inside that herb that is making that stuff work for you. And they are called phytochemicals. Now I was showing you paracetamol, the CCC stuff. That is basically the original form of these things. And if you are going to work with this kind of data, that is what you are going to use. And ways that you can generate data in chemistry is, let's say, database query. We have a large kind of database in science. And currently, I'm even working on one whereby we create chemical lists for natural products. So in creating chemical lists, I basically just write Python code to put paracetamol in front and then put the CCCC data in front, and then you create a whole lot of that, and then you probably create a generative AI model to develop another kind of seed for you that you can synthesize and be like, okay, can this work like a paracetamol or not? So it's in data in chemistry that we see fields like computational chemistry, chemoinformatics, drug design, material science. When we talk about chemoinformatics, it's similar to bioinformatics, but it's basically like using your data analysis skills and the likes to analyze your chemical data and your biological data. When we talk about computational biology or computational chemistry, you are basically developing algorithm to understand these data. There are more fields like that. Now, when we talk about data in physics, it's actually very, very complex. But it's in these fields that you will see all these astrologists, people that deal with space and the likes. Now, there are different kind of job roles in this field. We have bioinformatician, we have chemoinformatician, we have computational biologists, we have computational chemists, and the likes. Now, there is something peculiar with these roles. Like our former speaker said something like, you really do not need to have the background before you can work in this field. Well, it's a yes and no. Because yes, you can analyze your data, you can build your models, but can you interpret your results? When you put in a lot of C's and you get your C, how do you know whether the C's you get is right, the C's you get is wrong? How does it translate to like the real life scenario of human life? That is what I'm just going to say. So now, please, the next slide, please. So now, for these job roles, I basically underlined some facts. There are two things that are common with these job roles. Is your domain knowledge, like your basic domain knowledge, whether you have biology background, chemistry background, or whatever background you have in that field. It's not necessarily biology, chemistry, yes, but whatever background that you have, it's scientific. Coupled with your technical knowledge, you have to have a strong grasp of your data science skills, data analytics skills, and even go as far as ML and deep learning because they use it a lot in research. Now, I've said quite a lot of these things. What next? There are different ways that you can get into this field. And one of the ways is open source. Is there anyone here that does not know outreaching? Okay. So for outreaching, we have like 3 projects that are scientific based. My time is almost up. There's one called Bioconductor, and they do microbiology data curation. Obviously, you're going to read research papers, but $7,000 is a lot of motivation to read what you don't understand. Also, for GSOC, we have over 32 projects, and also On GitHub, you can find quite a lot of projects. Also, you can try competitions. We have Kaggle, we have Cindy, and the likes, and they do quite a lot of competition. Also, we have community. There's this quote that you can't go far if you are going alone or something like that. So there's a list of communities that you can join. You can check them out on Twitter, you can check them out on LinkedIn. And lastly, I have the learning resources here that someone shared with me, and I added my own path to it. So if you have your barcode scanner on your phone, you can scan this. Finally, I'll leave you with a quote from someone that I met recently that says that it is easier to train scientists about programming than to teach programmers about science. Thank you for listening.
Thank you very much, Zainab. Let's put our hands together for Zainab.